Alright guys, here we go. This is week 5 lesson 2, and what we're going to do today is we're going to go through one of these examples where we're actually going to find standard deviation. Again, if you don't remember, standard deviation is the average distance away from the mean for each piece of data, right? So it's how far away is everything from the mean, or how spread out is our data, right? That's how we find the standard deviation. Again, when we're looking at standard deviation, we're going to use this symbol right there called sigma, so we can write it and not have to write out. The standard deviation is this. So I only have one of these examples because they take a little bit of time, but really once you jump into it, it's not all that challenging. Since this is just our foundations class, I'm going to go through, use this table, and I'm going to recommend you guys use these tables all the time. It'll make it a lot easier, and we're not going to get into all the notation. We're just going to kind of go through the process so we can get to the meat of this is what the standard deviation is, what's it going to tell us about our data. So the example is, it just says, find the standard deviation for the following information. Again, we're trying to figure out how far is each piece of data away from the mean on average. So the way we're going to do that is we're going to look at the data that we're given, right? It says this is, and I've actually looked up this information online, you guys, just because I know you guys are starting to probably look at jobs, or you might even have jobs, but I just looked up some jobs online. And the hourly wage for jobs in Fresno that need a high school education and no extra experience, or just your GED, I got some prices here, right? You can get $14, $12, $13, $16, $14, $15, $9, and $18 an hour. Right, now notice how those are pretty close together. So the first indication in our head is standard deviation should be a smaller number, not some huge number, because they're pretty close. Whereas if we had something that was like some are $12, $15, and the others are like $80 and $90, that would have a much bigger standard deviation because those are a lot more spread out. So what we need to start with, your first step, I'm going to come over here and say first step is going to be let's just find the average, right? We have to start by finding the average, or our mu. Again, that's what we're going to use for average. So we add up all of our numbers, divide by however many there are. So take out your calculator, add up all of these numbers. So we're going to go 14 plus 12 plus 13 plus 16 plus 14, 15, 9, and 18. And that gives us 111. Make sure when you're finding the average, you divide by however many there are. So that's 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8, 111 divided by 8 gives us 13.875. Now, to make it a little bit easier on us, let's just kind of use 13.9 as our average. So our average is 13.9. Now, yeah, some of these numbers are going to get kind of challenging, but we're going to have a calculator. Just make sure you take your time. That's your first step. Now, notice over here in our table, we have that same symbol, that mu, what we use for the average. So right there, we're going to put the average in all of the boxes. So I'm going to come here and put 13.9 in all of these. Now, as you're going through this, you're going to notice that you're going to do some repetitive things. If you just want to write 13.9 and draw an arrow, knowing that you're going to use 13.9 for all of them, then do that. Okay, the second thing that we're going to do here is for x, right, for that column labeled x, we're just going to take all of our values and put it in there. So 14, you don't have to go through and put these in order. You're just going to put each of our pieces of data into this table. And notice how we can extend this table if we need to. Now we're just going to follow exactly what this table is telling us to do. Right, we have x, we have mu, or our mean. In this next column, it says x minus mu. So we're going to go 14 minus 13.9. And we're going to fill in the rest of the table following that same exact pattern. So what we have 12, 13, 16, 14, 15, 9, and 18. And we're going to subtract 13.9 from all of those, right? So this is why I'm saying we're kind of doing the same thing. The reason we're doing this subtraction here, as I'm writing out, is because we're trying to find the average distance away from the mean is. So the first thing is, what's the distance away from the mean that all of these pieces of data are, right? We're finding the actual distance. So now you go through, you have your calculator, and you're going to do 14 minus 13.9, which is 0.1, right? I trust my math, but gosh, 14 minus 13.9, my bad, 0.1. Come on now, Eberly. So I'm going to put 0.1 here. 12 minus 13.9. You have a calculator, okay? Negative 1.9. 13 minus 13.9. 0.9. Negative 0.9. 16 minus. So do you see how we're going to be doing the same thing here? The steps really aren't all that bad as long as you can follow this table here, and you're going to be using a calculator. 15, 13.9, 1.1, 9 minus 13.9 is negative 4.9, and then 18 minus 13.9 is 4.1. So we have all of that. The last thing we're going to use this table for is we're going to square all of those numbers we just found. So that 0.1, we're going to square it. That negative 1.9, square it. So the table makes it nice because we have it organized, and it makes it so you can kind of just follow those directions that we have at the top there. Now again, notice how we have decimals here. That's okay. Not everything is going to work out to be perfect numbers. We'll just round them as we go. So we square all of these. And the reason why we're only doing one of these problems is because the steps are going to be the same no matter what the numbers are, and they can get a little bit redundant. And I'm only going to have you guys practice a couple of them at a time. So now we square them. Again, you're just going to go 0.1, hit squared in the calculator. That's 0.01. Here, maybe I should use a different color. We'll go back to orange. Oh no, we'll go blue. 0.01. Now we go negative 1.9 squared, 3.61. Now when you do these, every time you square something, it should come out to be a positive number. We should end up with no negatives here, so just keep that in mind. 2.1 squared, 4.41. 0.1 squared, we've already done that, that's 0.01. 1.1 squared, I'm guessing it's like 1.21. 4.9 squared, 24, and then 4.1 squared. So really this ends up just being a good amount of calculator work. Now, we subtracted each piece of data away from the mean because that tells us the distance, right? We squared it all because now what we've done is we've gotten rid of all of the negatives. Now we're only looking at positive values. Again, our goal is to find what's the average distance away from the mean. So the next thing we're going to do here is we're going to take all of these blue numbers after we've subtracted and squared them, and we're going to add them together, right? So we're just going to add them together and find the average of that. So we're going to take all of these, add them together. I know this is a lot of calculator work. I'm doing it along with you guys so you can kind of see what the process is and take your time going through it with me. 3.61 plus 0.81 plus 4.41 plus 0.01 plus 1.21, 24, and 16. Oh no, I messed up. Gosh. 16.81. Oh, come on, guys. So again, make sure you're just being careful here because I have to go through and add this one more time. As I'm doing this, I will try my best to take my time. You guys need to take your time as well because obviously I'm not being careful 15.01 plus, here we go, 16.81 equals, we get 50.88 all added up. So we've added them all up, and we're going to find the average, right? So there was 1, 2, 3, 4, 5, 6, 7, 8 numbers that we just added up. We're going to go 50.88 divided by 8. We're finding the average. That gives us 6.36, right? 50.88, let me double check so we don't make any mistakes. 6.36, we're very close to finding the standard deviation. The last thing that we have to do here is, since we squared everything, we undo it by taking the square root. So you go in, you do the square root of 6.36. Sorry about that notification there. And you get something like 2.52. And let's just cap it there. So we end up getting 2.52. That is your standard deviation. I'm going to put the approximately 2.52. So again, what we did there at the end was we got all of those numbers that we squared, right? We had subtracted them from the mean, squared them all, and then we just find the average of those numbers, find average of the numbers that I put in the blue box there. After you find the average, you square root it. That right there is your standard deviation, which is a smaller number that we thought, right? Which means all of those starting hourly wages are about $2.50 away from the average rate, which the average rate was about $14. So you're within $2.50 from that 14. Whether that's 2.5 below or 2.5 above, that just depends. And that standard deviation makes some sense compared to our data there. Again, make sure as you're going through and you're finding the standard deviation, you use one of these tables, because it'll make your lives a lot easier, and you're kind of just using, going through and following the steps there. We're going to look at some more examples in the third lesson, but we're going to just keep doing standard deviations. That's what this week is focused on. If you have any questions, let me know.